it going, everybody? All right, last type of ionic bonding that we're going to learn about is polyatomic ionic bonds. All right, and in a polyatomic ionic bond, we are still dealing with ions, and ions are our positives and negatives. But now we have something new. So before we've been doing binary, which was metal and nonmetal, and we did transition, which was transition metal and nonmetal. Now we are dealing with polyatomic. And in the word polyatomic, poly means many, and atomic obviously means atoms. So we're going to be dealing with many atoms in our ionic bonds now. So in a polyatomic ion, these are ions consisting of two or more atoms that act like a single unit. Okay, so you need to take out your periodic table and you need to take a look at this box right here. This is the common polyatomic ion box. Now, what you will notice is that almost every single one of these polyatomics here are negative. So most of these, with the exception of ammonium, are going to be anions. So most are anions, with the exception of this one. This is the only positive polyatomic ion. So this is the only cation. Everybody else here is negative. Everybody else is an anion. Now, what I mean when I say ions consisting of two or more atoms that act like a single unit, well, these are going to act like single units. So Cr2O7 is going to stick together. ClO3, it's going to stick together. So in order to name, to find the name in charge of a polyatomic, we need to locate the common polyatomic ion box of the periodic table, which is here. Carefully locate the correct polyatomic. So for example, if we're looking at the example here for chlorate, in this box, I'm going to search for chlorate. Here it is. Now be careful because there's a hypochlorite, a chlorite, a chlorate, and a perchlorate. Okay, so you have to pay attention to the word and the endings and the beginnings of these polyatomics because they're all different. So here's chlorate, and chlorate is ClO3 with a -1 charge. So it's ClO3 -1. Phosphite, we look at our periodic table. Phosphite, if we look, phosphite, here we go. We have PO4 -3, which is phosphate, and PO3 -3, which is phosphite. So you have to pay attention to the ending. The ending here is ite. So we have PO3 -3. Okay. Next one is ammonium. So this is the one that's different. This is the one that's positive. So ammonium is NH4 + 1. And then hydroxide is the last one that we're going to be looking for. Hydroxide is right here. Hydroxide is unique because hydroxide sounds like hydro and oxide. And that's exactly what it is. Hydroxide is OH -1. Now you need to be careful with hydroxide because it's not a single hydrogen, it's not a single oxygen, it's hydrogen and oxygen together. Now, if we take a look at the box here, with the exception of ammonium and hydroxide and cyanide, almost every single one of these polyatomics ends with what? Most of them end in 8 or ite, except hydroxide, cyanide, and ammonium. All right, everybody else ends in 8 or ite. So if we take a look at these polyatomic ions that we have here, every single one of these polyatomic ions consists of multiple atoms. Not only do we have numerous kinds of one atom, but they're usually always paired up with another one. So what I mean by acting like one unit, you know how when we've been bonding, we have Na+ and Cl-, and they go together. This cancels each other out. Well, now what we're going to do when we start to bond is our ClO3, our chlorate, is going to act just like the chlorine did. And it's going to act like one unit. So what you would end up doing with these two compounds is just putting them together since they cancel. All right, so now we're going to start building the actual compounds. So ionic polyatomic compounds are compounds composed of cations and anions that have 3 or more elements bonded together. Okay, so first step to form a polyatomic compound is to write the cation with its charge. And the cations are typically going to be metals. So here's our cation, it's lithium. So we have Li plus 1. Then step number 2 is to write the polyatomic with its charge. So here's my polyatomic, it's hydroxide. So what I'm going to do is I'm going to look for hydroxide in my common polyatomic ion box, and here it is. Here's hydroxide, and hydroxide is OH minus 1. So I'm going to write that down. Oh, we got an announcement in the background. Go get your crock pot. All right. Anyways, sorry if you heard that. Okay, so back to bonding. If we have lithium plus 1, OH minus 1, what happens? So just like before, if we have plus 1 and minus 1, these end up canceling. So I'm going to do the same thing that I did with an ionic or transition, is I'm just going to put them together. It's LiOH. Plus 1, minus 1 cancel, so this is my new compound. All right, let's take a look at the next one. We have potassium. Potassium is K plus 1. Now we need to look for chlorite. Chlorite is here. Chlorite is ClO2 minus 1. So I'm going to write ClO2 minus 1. All right, so these two, I have plus 1, minus 1. So what do I need to do to put these together? Well, they cancel. So again, like we've been doing the last couple of days, is I'm going to do K, ClO2. There we go. That's all I have to do. Put them together. All right. All right, next one. Name the metal. Name the cation. It's always a metal unless it's ammonium. So here we go. We got aluminum. So this is aluminum. Now I do not need Roman numerals for aluminum because aluminum is not a transition metal. It's just a regular old metal. So I don't have to figure out what its charge is because aluminum is always plus 3. So if it's not a transition metal, then all I need to do is figure out what the name of this NO2 is. And NO2, if I look on my periodic table, is right here. It is nitrite. So this compound's name is aluminum nitrite. All right, next compound. This one's one of my favorites, nacho. This one's nacho. So what I'm going to do is I'm going to name the metal. What is the name of this metal? Na is right here. It's sodium. Now, is sodium a transition metal? No, it's not. So it does not need Roman numerals because it is not a transition. So once I've named my metal, then I need to look on my common polyatomic ion box and figure out what C2H3O2 is. Now be careful because there's the C6H5O7, that citrate, whereas C2H3O2, like what's right here, is acetate. So the name of this compound is sodium acetate. All right, so there you have it. That is how you form compounds and how you name them. All right, so if you get it, you can move on to the worksheet that says polyatomic ionic bonds. It's worksheet number 4, which is right here. I'm going to do a couple more examples on it so that you can see, but if you've got it, because here's one of our ammonium ones, if you've got it, then you can move on. All right, so this whole front page, you're taking the compounds and then you're naming them. So this one, I'm going to name the cation. Now, I am not going to name the metal because nitrogen is not a metal. So if I know nitrogen is not a metal, I can't name it first. So that means that that's probably because NH4 is a polyatomic, which it is. NH4 is ammonium. So I'm going to name this. This is ammonium. So I've named this first part, so then I need to look for the second part. And CN together is a polyatomic. It is right here, it is cyanide. So this compound is ammonium cyanide. All right, Mg, not a transition metal, so we got to look up what magnesium is. Magnesium is +2. So this is Mg +2. Nitrate is a polyatomic, which is NO3 -1. O3 -1. Okay, now +2 -1 do not cancel. So what do I need to do in order to get them to cancel? I need another NO3, the -1 charge. So when I write my formula, I need 1 magnesium, 2 NO3. So I'm going to write Mg, and then I'm going to write NO3. Now, I just said I need 2 of them. So can I just put a 2 on the outside and call it a day? No. Can I change this subscript here to a 2 and call it a day? No, because if I change NO3 to NO2, I no longer have nitrate. I now have nitrate. So I need to add parentheses around the outside. All right, if you get this up to this point, you're pretty good. If you're still having issues, then you need to come get some help before you move on.